Hello students, welcome to Analytical Chemistry class. Today class we will discuss an important topic of chromatography, that is your thin layer chromatography. This is also known as TLC. So using thin layer chromatography you can identify the compounds present in a mixture. If the mixture contain a number of compounds, you can separate and qualitatively identify the components present in a mixture. What are the prerequisites of today class? So you should have the basic knowledge of chromatography and what are the basic terminology used in chromatography, what are the classification of chromatography, and what are the different principles used in chromatography. So what are the learning outcomes after the class? So each and every student explain what is TLC and what is the principle of TLC, explain the procedure how to perform TLC of a mixture of compound, then also discuss the advantages and application of TLC, then apply the principle of TLC for separation and qualitatively identification of organic compounds. So chromatography is a technique which is used to separate and identify the components present in a mixture. So on the basis of chromatography bedsheet, so it is of different types, two-dimensional chromatography and three-dimensional chromatography. So thin layer chromatography, paper chromatography, these are will come under two-dimensional chromatography, and under three-dimensional chromatography, so column, that is column chromatography, it is come under three-dimensional chromatography. So that means here you see using this thin layer chromatography, these are the different advanced technique. So this is your known as your HPLC, that is your high pressure liquid chromatography, and this is HPTLC, which is your high performance thin layer liquid chromatography. So these are the advanced techniques of chromatography. So using these instruments we can just quantify the compounds or components present in a mixture. So these are the chromatograms. So what is the thin layer chromatography? So see here, thin layer chromatography, it is the separation of volatile and non-volatile substance based upon different adsorption techniques on an inert solid phase, that is known as your stationary phase, which will emerge in an organic solvent or a mixture of solvent, that is known as your mobile phase. So first in a 1938 thin layer chromatography is introduced by Ismailov and Schreiber. So who introduced thin layer chromatography in 1938? So this TLC, what is the basic techniques in TLC? It is a technique in which the components of the extract will be distributed between two phases. One is stationary phase and another is mobile phase. So this TLC involves a stationary phase of thin layer absorbent, and in this the absorbents are like silica gel, alumina, cellulose, or on a flat inert substrate. That means here in this we can use the stationary support, we can take glass plate or aluminum plate, and over this stationary glass plate or aluminum plate there is a coating of this silica gel or alumina. So this TLC plate, we can also in laboratory also it can be prepared. So the slurry of silica gel will be prepared, then it will be coated over the glass plates. So then it will dry. Then after drying, so we can use this plate for TLC identification. See here, this is a TLC chamber and that is mainly made up of glass, and this is the TLC plate where the sorbent, the adsorbent, your silica or alumina. Then this is the solvents that is known as your mobile phase. So the compounds will separated by the capillary action of the solvent. When the solvent will move up, the components will get separated. Okay. When we plot the TLC, when we just spot the compound in the TLC plate, so there some precautions should be taken. That means the compound, the components will be the mixture, it will spot in a certain distance so that it will not deep inside the solvent. So this precaution should be taken when we do spotting in TLC. Then what is the principle of TLC? So the principle of separation here is adsorption. Similar to other chromatography method, TLC also based on principle of separation. This separation depends on relative affinity of compounds towards stationary and mobile phase. So how long the stationary phase will adsorb the compound, then what is the affinity of the mobile phase, how fast it will dissolve the compound. So on the basis of this, compound will be separated and move on the TLC plate. And also separation of the compound also depends upon the polarity of the mobile phase. So in a mixture there are different variety of compounds, non-polar compound and polar compound. So if we will take the non-polar solvents, so like dissolves like, so if we will take non-polar solvents, what will happen? Non-polar compounds will be separated fast. And if we will take the medium polar compounds, so non-polar compound will separated, but the polar compounds will be get rise from the spotting, but it will not move so far. So that means on the TLC plates the compounds will separated on the basis of the polarity. That means polar compound will move slowly and non-polar compounds will move fast. This is the spotting line, and this is the mobile phase under TLC plate, and this is your TLC chamber. So during these movements, the compounds with high affinity towards stationary phase, that will travel slowly while others travel fast. So the separation of component in a mixture will be achieved. Once the separation occurs, so then after the separation, then sometimes the spots are visualized to our naked eye, and sometimes also some compounds are UV active, and we will just do the visualization in UV chamber after drying the plate. Then there is also some spray reagent will be used for detection of or identification of components in the mixture. So their nature and characteristics are identified by means of suitable detection techniques. What are the requirements for TLC? So main requirements are stationary phase and glass plates, preparation activation of TLC plates, application of the sample, then development tanks, mobile phase, development techniques, and detecting reagents. Detecting agents are required after the development, because if some compounds are not UV active and some compounds are not visible, so detecting reagents or spray reagents are used for visualization of that compounds. Then what are the steps of TLC? So TLC consists of 3 steps. One is spotting, another is development, and last one is your visualization. So let us first discuss how we spot the compound on the TLC plate. So in TLC, the sample must be carefully applied to the plate to minimize spreading of the sample. So sample size, that means minimum concentration, sample should be prepared for of minimum concentration. That means 0.1 mg to 50 mg are the best sample preparation techniques. If when you are preparing the sample, you should take 1.1 mg to 50 mg and dissolve in a minimum volume solvent. So smaller amounts are difficult to visualize, while sometimes larger spots will lead overloading and variable results. So if we take just a large spot, then the separation or resolution will not good. So samples should be dissolved in relatively volatile solvents. That means minimum volume of solvent, there are 0.5 to 5 ml. So that the spots, so that if we'll just make minimum concentration of sample, then the spots will not spread excessively. So the spots should be spot around 3 to 4 mm diameter. So this is the technique. By using a capillary tube, we'll spot the sample in the on the TLC plate. Then how will develop the TLC plate? So this is your TLC chamber. This TLC chamber is made up of glass. So before developing the plate in the chamber, first the mobile phase will put in the mobile phase will be taken in the chamber to make the chamber saturation. So after chamber saturation, then the plate will develop inside the TLC chamber. So the spotted plate is placed in a sealed development tank which is filled with vapors of mobile phase in its lower side. So in the lower side of the plate, the solvents or mobile phase will be there. So that the solvent will level below the applied sample spots. So the whatever the solvents will take in the chamber, that should be below the spotting of the TLC plate. The solvents here rise due to capillary action, and this process is called development. So this development time generally it will from 3 to 60 minutes. So after the development, the plate will dried by a dryer. After development of TLC plate, next step in TLC is visualization. So visualize some compounds that will visible in naked eye. If there is color band, so they will move and we can just visible it on our naked eye. But some compounds that will be visualized under UV light. So that is known as a fluorescent compounds that will observe under UV light. There is two range of UV light we will use for visualization TLC. One is short wavelength that is around 240 nanometer, and is long wavelength that is 360 nanometer. So this when will just after development will dry the plate and see under different wavelength range of UV light and then identify the spots. Then there is some chromogenic reagent, that is some chemical reagent which is used for visualization. That reagents react with the compounds and give particular colors. So these reagents is general, or there may be selective reagents that for selective functional groups. For alkaloids, we can use drag and drop reagent. There is some functional groups for which we will use alkaline KMNO4. So that means different functional groups have different spray reagents, or this is known as your visualizing reagents. So there is also some organic material which can also use for spraying. That means some TLC for some TLC we can use sulfuric acid spray. That means 5% sulfuric acid or 10% sulfuric acid spray we will use for some compounds. Then after spray we will just heat the TLC plate. Then after heating we will just analyze the TLC spots in the TLC plate. Then some compounds like amino acids, for amino acid ninhydrin spray is required. After ninhydrin spray, the plate will be dried or heated in a hot air oven, and then the separated compounds will be identified from their color. Then how we analyze the compounds in the TLC plate? So you see here there are in a plate there are several number of plates. So how we will analyze them, and what is the nature of the compound in TLC plate we will analyze. So here that is known a factor that is known as your retardation factor or RF value. So what is RF value? This is the distance travelled by a solute and the distance travelled by the solvents. So that is RF is your D-solute by D-solvent. Here you see you have spotted the compound here. This is the origin of the compound. Here this is the starting line. But the solvent move from here to here. So this is the distance travelled by the solute, and this is the distance travelled by the solvent. So distance travelled by the solute and distance travelled by the solvent give you the RF value. So from the RF value we can just identify which is a polar compound, which is a non-polar compound. See here for this compound RF value is high because it moves faster. For this compound RF value is low. When we will compare the nature of these two compounds, this is a low polar compound and this is a high polar compound. If we will just take here the silica gel plate. So here these are the different separation of compounds in a mixture. The RF value has to be between 0 to 1. So the RF of a compound is never more than 1. So it is between 0 to 1. Then what are the advantages of TLC? So thin layer chromatography has several advantages. It is a simple process with short development time. It helps in visualization of separated compounds or spots easily. This method helps to identify the individual compounds. It helps in isolation of most of the compounds. The separation process is faster and selectivity for compounds is higher over small difference, and it is a clean separation. The purity standards of the given sample can be assessed easily. So it is a cheaper chromatographic techniques. So these are the advantages of thin layer chromatography. Then what are the application of TLC? So TLC is mainly it is a qualitative identification of compounds in a mixture. So to check the purity of the given sample, that means whether the compound is pure or impure. If it is a impure compound, so various number of components will be separated, and it will, after the TLC, the mixture will give number of components. If it is a pure compound, then we will get a single spot. Then identification of compounds like acids, alcohols, proteins, alkaloids, amino acids, amines, antibiotics. So all these can be done by the help of TLC. Also we can apply the TLC for evaluate the progress of the reaction. So the reaction process by assessment of intermediates or reaction time. So that means the progress of a reaction can be evaluated by applying the TLC. Then to purify samples, for purification process also there is a process that is known as your preparative TLC. So in preparative TLC we can also purify the compounds. Then also this TLC or to keep a check on the performance of other separation process. So there are several applications of TLC. So nowadays we are using some advanced techniques of TLC. For this class, you can follow these references. This is the Analytical Chemistry by G.D. Christian and Exploring Chemical Analysis by Harish DC, and also Basic Concept of Analytical Chemistry SM cover. So these books you can follow for preparing this class, and also these are the sources of internet which are also followed for preparing the material. So these are the references you can follow for this class. Thank you all.